Good afternoon, everyone, and welcome to the S2S4E Winter Outlook webinar. I'm Andrea Nicodemou from the Barcelona Supercomputing Center, and in the next hour we will present the sub-seasonal forecasts for the next 4 weeks and the seasonal forecast for this winter, which will cover December, January, and February. We will then have a short poll and Q&A session. And in the second part of the webinar, we will discuss the Euro-Atlantic teleconnection forecast and show how our summer extremes service helped anticipate temperature extremes in summer 2020. And this will be followed by our final Q&A session. To ask questions throughout the webinar, you can use the question or chat panels on GoToWebinar. And with us today, we have Andrea Manrique and Llorenç Lledó from the Barcelona Supercomputing Center. Andrea Manrique has a physics degree from the Universitat Complutense de Madrid and a PhD in meteorology from the University of Reading. At the BSc, she has been working on the use of climate predictions for climate services, particularly in calibration and forecast quality assessment. Llorenç Lledó is a climate scientist at the BSc, studying the application of seasonal predictions to the energy sector. Before joining the BSc, he worked in the wind power industry for 10 years in wind resource assessment and power forecasting. And now we'll give the floor to Andrea and Llorenç, who will present the forecast. Andrea?
Yes, thank you, Andrea. Welcome, everyone. So I'm going to begin by introducing the sub-seasonal forecast for the next 4 weeks. From data is the forecasts are from ECMWF forecast system. So we'll begin with temperature. So for the next week, this week actually, we are expecting high probability of temperatures being above normal, especially almost everywhere in Europe, especially North Atlantic. And there is some probability of temperatures being below normal in Italy and the Balkan region. For the week of the 30th to 6th of December, we are expecting high probability of temperatures being above normal, particularly in the Scandinavian countries, where there's also some risk of extremes. Additionally, in the Balkan region, there is some persistence of high probabilities of below normal temperatures. For the week of the 7th to the 13th of December, there is a generalized high probability of temperatures being above normal all over Europe. For the week of the 14th to 20th of December, almost going into Christmas, there is some probability of temperatures being above normal in the southern part of the Scandinavian countries. I carry on with wind speed. For this week, we are expecting high probabilities of below normal wind speed in most of the southern part of Europe, except some areas in the northeast, where the probabilities are indicating above normal, higher probabilities of above normal wind speed. For the week of the 30th of November to the 6th of December, there's still some indication of below normal wind speed in the Mediterranean area, and the probabilities are indicating higher than normal wind speed in the area of the North Sea and Scotland. For weeks 3 and 4, there is not much signal from the forecasts. We move now to precipitation. For this week, we are expecting high probability of below normal precipitation, so quite a dry week in most of Europe. For the week of the 30th to the 6th of December, there is generally indications of below normal precipitation, and some areas of the North Sea, Scotland, and Norway with indications of above normal precipitation. For the weeks 3 and 4, there is not much signal from the forecast. Now we move on to solar radiation, and for this week we can see that for most of Europe The probabilities are on the upper tercile, so we are expecting higher than usual solar radiation, particularly around the Mediterranean, south of Europe, but the signal spreads for most of Europe. For the week of the 30th to the 6th of December, we can see still indications of a high probability, not such a big strong signal, but we can see we expect above normal solar radiation. Then for weeks 3 and 4, there is not much signal. So we move now on to the seasonal outlook, and I hand over to Llorenç.
Yeah, thanks, Andrea. So for seasonal, we are showing here the predictions that were initialized on 1st November by the European Center Seasonal Prediction System, which is the SIS5, the System 5. This slide is showing the forecasts for temperature for December, January, and February. For December, we can see a strong signal in the north of Scandinavian countries with high probability of above normal temperatures in that region. Whereas in the rest of Europe, there is not much skill, no information shown on the map. In January, we can see a strong pattern in the Mediterranean, in the Western Mediterranean area, south of France, parts of Italy, with also enhanced high probability of above normal temperatures in this region. Whereas the other areas show enhanced probabilities for normal, or just they do not show preferred conditions, so similar to climatology. And for February, there is a strong signal in Estonia and in Finland. Also, again, high probabilities of above normal temperatures. So you can see that for these 3 months, for those regions where we have skill, we can see mostly signals of above normal temperatures. Now we move to wind speed. So the picture for wind speed for December is not clear at all. The maps show some high probability of above normal wind speeds in Czechia, Hungary, parts of Croatia, but it's a very small pattern here, so nothing really to outline for December. On the contrary, for January and for February, we see high or enhanced probabilities of above normal wind speeds in most of Central Europe. In January, we see that in Ireland, in Germany, Poland, Denmark, south of Sweden, Latvia. And for February, we see also the similar forecast in these regions, in the central of Europe. That's especially strong in February for Germany. We move to the precipitation forecasts for the next 3 months. Again, here, December and January, no clear signals in the continent. There are localized signals, I would say. For instance, in December, we can see enhanced probability of dry conditions in the northeast of Spain, where we live, both Andrea and myself. But there's no clear pattern. But I want to highlight here that there is a strong signal for February. In the south of Norway, there is a very strong signal for above normal precipitation. It's a forecast that is very sharp. That means that the probability of observing above normal precipitation in that region is above 70%, which for a seasonal forecast, it's outstanding signal. And also, this is a region where the forecasts have a lot of skill, up to 20% of RPSS, which is the skill score that we are using. the S2S4E project for these tercile forecasts. So that is an outstanding forecast with very high probability and very good skill levels. I also want to highlight for February the enhanced probabilities of dry conditions in the Iberian Peninsula and also in some parts of the Mediterranean. And I will show you later how that relates to the NAO forecasts that we have for the next months. And finally, for the radiation forecasts, in December, you can see that there is a blue area in the north of the Iberian Peninsula, in the west of France, also in parts of the Scandinavian countries, indicating enhanced probability of below normal radiation conditions. In January, we don't see a very clear pattern. And in February, I think that it's good to highlight the below normal radiation conditions that can be expected in Germany, where we can see a quite consistent pattern of below normal, enhanced probability of below normal radiation conditions in Germany. That's what I would highlight from this February forecast. Yeah, with that, I think we are now at the end of the subseasonal and seasonal forecast. So I give the floor back to Andrea.
Hello, thank you, Andrea and Llorenç. So now we have a few questions. The first question is for Andrea. What scale do the subseasonal weekly predictions have?
So all the maps that were shown here had positive skill. So we mask out any negative skill. And then the skill depends a lot on the lead time we are looking at. So it decreases the farther we go in time, and also it depends on the variable. So typically for temperature, we have higher skill than for other variables.
Right, thank you, Andrea. Then there's another question, I think that's for both of you. Do you add any information in the subseasonal and seasonal forecast, or are they raw outputs from ECMWF model?
Okay, I can take this. Yes, no, the raw data has to be calibrated. So we do a calibration process to remove the biases, especially at these timescales. It's important to calibrate. So it's not raw data. Both the subseasonal and the seasonal forecast have undergone a process of calibration.
Thank you, Andrea. Do you have anything else to add, Llorenç, on this question?
We've seen in the past that sometimes the calibration process changes a bit the big picture that you get when looking at the raw data, and that is something that we've been investigating. And of course, this is something good, because it means that our calibration changes the signals that we see in the raw data. Hopefully to get it better.
Thank you. And we have a related question. Could you tell us in simple words what you mean by calibration?
Yeah, so the bias adjustment process has two main goals. One is that of reducing biases, mean biases, and another that has to do with the ensemble spread. Yeah, calibration typically refers to adjusting the ensemble spread so that the probabilities that you forecast are consistent with the observed frequencies of the events that you are forecasting.
Yeah, right. I can add just to add to that to explain the process. What we do is look at forecasts in the past for which we have observations, and then with a period in the past we're able to identify those biases or that lack of a spread or excess of a spread and correct it based on past performance for the future forecasts.
Right, thank you, Andrea and Llorenç. And the final question, can you please explain the MSL forecast for December, January, February?
We have not prepared explanations for that, but maybe when we talk about the Euro-Atlantic teleconnections, we will be indirectly showing that the forecast is of high probability or enhanced probabilities of high pressure in the south of the Euro-Atlantic region. I will try to comment on that later on when we talk about the Euro-Atlantic teleconnections.
Great, thank you. And also to remind everyone that you can access the S2S4E Decision Support Tool, where you have more variables and other forecasts. And we have two more questions very quickly. Which data set observed do you use to identify the biases and the wrong calibration of the ensembles? Is it ERA5?
Yes, exactly. It's the ERA5 reanalysis.
And finally, could you expect a very different winter forecast next month?
Well, that is a tricky question, but I will be brave and say that no, that I would not expect very much changes. But I will base that on also again on the results that I will present later on the Euro-Atlantic teleconnections. Indeed, we are now in a situation where the ENSO is on a negative phase, so we have a La Nina phase ongoing in the tropical Pacific, and that is an event that modifies the extratropical circulation in the northern hemisphere. And so that the forecast for the ENSO is that in the coming months it will continue to be a negative phase of the we will continue to have a La Nina event, and that is probably a good signal that will bring consistency to the forecasts. But again, the question is tough. That is my best guess.
Thank you. So now we have a short poll. That if you can answer some questions, I will launch the first question. So for historical analysis, are you using weather regimes, teleconnection indices, or other pattern-based techniques? I will give you a few seconds to respond. Okay, so we're getting lots of responses in. Just a few more seconds and we'll go to the next question. Okay, thank you everyone for responding. And then the next question, are you using forecasts of weather regimes, teleconnection indices, or other pattern-based techniques? And if you can please select one of the following, yes, no, or if you're willing to use them in the future. Right, thank you everyone for responding. So the final question is, if you answered yes in any of the previous questions, which of the following pattern methods do you use? Weather regimes, teleconnection indices, analogs, other, or none of these? Well, if you answered no. Great, thank you everyone for responding to the poll. So we will now go on with the teleconnection forecast. Llorenç?
Okay. So I'm gonna tell you a bit about the 4 teleconnection indices that we are using in the project, and I will be showing forecasts for the DJF for the whole winter for these teleconnection indices. So we have used 4 teleconnection indices in this project to summarize the state of the atmospheric circulation in a season. Those are the patterns associated to each of these teleconnections. The North Atlantic oscillation, the East Atlantic pattern, the East Atlantic Western Russia, and the Scandinavian pattern. And you can see here the 500 geopotential height anomalies which are associated to each of these teleconnections. And the idea is that each of these teleconnections has an impact energy system, a different impact on the energy system. And I'm showing this here, for example, for the surface wind. So this is the impact of each of the 4 teleconnections on surface wind in January. For instance, positive phases of the NAO are associated to high winds in Central Europe. But I also want to show that, for instance, positive phases of the East Atlantic, Western Russia are also associated with low wind speeds in the English Channel, north of France, and the south of England, or Scandinavian patterns, positive phases which can have an impact on wind speeds in the eastern parts of Europe. So while the North Atlantic Oscillation is a very widely known teleconnection, sometimes it is not enough to describe the whole picture in Europe. And so in this project we have tried to go further by providing forecasts of these 4 teleconnections that are relevant in the Euro-Atlantic region. And now what I'm gonna be just the impacts of the teleconnection indices on other variables that are relevant for the energy industry, such as temperature, solar radiation, etc., can be found in a public deliverable of the project. You can find that in our website. It's deliverable 3.2. I will start with NAO forecasts from 5 different systems that we got from the Copernicus Climate Change service, from the climate data store of the Copernicus Climate Change service. As I said, those are the forecasts issued on November 2020 for DJF 2021, and each of the panels shows one prediction system: the System 5, the Deutscher Wetterdienst model, Meteo France model, UK Met Office model, and CMCC model. And we have grouped here the different ensemble members, the answers that they give for the NAO status, into terciles, so similar to what we do in the Decision Support Tool. And in this case, we can see that the answers that are given by the different systems are quite consistent. There is consensus that there will be that there is enhanced probability of a positive NAO phase. And all systems indicate like 40 to 50% of probability of this happening. So of course it is not sure that we will have a positive NAO, but it's more probable having a positive NAO than having a negative NAO. And also those plots, if you look at the top, you have here the ensemble mean correlation and the rank probability skill score for each of the prediction systems. You can see that for the NAO forecasts, the rank probability skill scores range from up to 8%. I classified that as a skill positive but limited. I will show now the forecasts for the Scandinavian pattern. And in this case, there is no clear consensus. So there are three systems that show enhanced probability of a negative Scandinavian pattern, and 2 that show the opposite picture. So now it is not very clear what will happen. But then, if we look at the prediction systems that have the better skills, which are the German and the British models, the UK Met Office and the DWD, we see that both suggest enhanced probabilities of a negative Scandinavian pattern. I'll continue with the East Atlantic forecasts. In this case, there is no consensus at all. Each system is showing different things. And if you look at the skills are very bad for this teleconnection index. So you'd better not use this information at all. And finally, for the East Atlantic, Western Russia, there is again a good consensus, and there is a strong signal. indicating high probability of a negative East Atlantic Western Russia pattern. The probabilities range from 40 to 65%, depending on the system. And you can see that in this case, we have skill levels quite limited, except for the glossy 5, which has a 7% of RPSS and gives a 50% of probability of below normal East Atlantic Western Russia. Okay, and here I show you the predictions made by combining the information from all the systems. Is what we call the multi-system predictions for the 4 teleconnection indices. And you can see that in this case, we managed to have positive RPSS for the NAO, the East Atlantic Western Russia, and for the Scandinavian pattern. For the East Atlantic, we have 0% of skill, so I would suggest to disregard the East Atlantic forecasts and just look at the North Atlantic oscillation, East Atlantic Western Russia, and Scandinavian. The summary is that we have enhanced probabilities of having a positive NAO, enhanced probabilities of having a negative Scandinavian pattern, and high probabilities of having an East Atlantic Western Russia negative phase. And I want to, as a bonus, this is very consistent with the forecasts that we issued in September, so 3 months ago, which showed very similar probability distribution functions, very similar shapes, and very similar numbers of probability. So the picture that we would have seen 3 months ago would have been very similar to the one we are getting now, and that's why I was saying before that I expect the forecasts to be consistent next month in December. And that is probably related to the signal that the negative phase of the ENSO is playing this season. And yeah, I wanted to finish by showing what could be the combined effect of a positive NAO phase and a negative Scandinavian phase by using this figure from Laura Zubiate in a paper from 2017. I think that we are heading towards a situation close to C panel in this figure with a negative Scandinavian index and a positive NAO. And you can see that the wind speeds anomalies are quite strong in this case. This is consistent with what we saw in the DST for wind speed forecasts in January and February. And we also saw that in the precipitation, where we saw in February especially, we saw a forecast of wet conditions in the Scandinavian, in Norway especially, and dry conditions in the Iberian Peninsula in the south, which are also consistent with these Euro-Atlantic teleconnection forecasts that I showed. Yeah, I hope that you find that interesting. If you have any feedback, please, I would be very happy to hear on the questions.
Thank you, Llorenç. So it's Andrea here, and first I would like to share the results of the poll before we move on to Andrea and the summer extremes. So in the first question, most of the participants replied that they are using the weather regimes and teleconnection indices for the historical analysis. Then in the next question, most of the participants are either using this forecast or willing to use them. And finally, in the final question, we see a mix of different methods being used by the participants. I don't know if you have any comments on that, Llorenç, or should we move on to Andrea?
I wanted to thank the participants for providing the answers to these questions. I think this is something that is very useful for us to know if it's worth continuing our efforts working with these pattern-based techniques in future research. So thank you.
Great, thank you. So I also want to comment that at the end, you will receive a survey after the webinar finishes. If you could please respond to that. That's on the DST and the use that you you make of this service. So it would be very useful for us if you respond to that as well. So Andrea, I give the floor to you again.
Okay, thanks. Okay, so now we move on to an evaluation of summer extremes. So I'm taking you back to summer. So this is a service we started in June, where we wanted to complement the DST with some information about the probabilities of having episodes of extreme heat. So the service was giving information about the probabilities of episode of extreme heat for the next 4 weeks, and it was given through the website, and also it was communicated via Twitter every Friday. So I'm going to show a bit of an evaluation of how this service went. And just to recap, during this summer 2020, there were some events, particularly in the northern countries, the UK. We can see here some headlines of Scandinavia reaching very high temperatures. Also, this is a picture of the beach in Bournemouth in August. And also, this is some information from Public Health England about an excess rate of above 2,000 deaths during this summer. So, well, there was a strange situation with coronavirus and also the extreme heat. So it's a combination of events, but it highlights the importance of this type of information. And so we've identified 3 events or episodes of during this summer, which are there on the right. So at the end of June, there was particularly affecting the northern countries, Scandinavia. In August, more towards the central part, also the UK. And also in September, again, there were some days of temperatures above normal. So, and these images here are from ERA5 reanalysis, so they are showing the anomalies. And I'm going to show you here what the actual forecast anomalies were like. So hopefully you can see this now, these images. So the last image is the observations, so based on reanalysis. And then the 4 images preceding it are the forecast issued 4 weeks in advance, 3 weeks in advance, 2 weeks in advance, and the week before. So as you can see from weeks 3 and 4, there's not really a clear picture of the warm episode that is coming. But then week 1 is quite good. So as in terms of intensity and also locating, now we can see how the first event in June was also indicated to happen in the northern parts. For the episode in August, also it's quite well defined. Same in September, which was also affecting mainly the center. For week 2, only in the case of August, we could see some indication 2 weeks in advance of these warm temperatures occurring. Now I'm going to show, we'll focus on some cities, and we'll see the evolution of these temperatures throughout summer. So first of all, Stockholm, as we saw in the previous image, it was mainly affected at the beginning of the season. So I'll explain a bit what this figure is showing. So here we have the temperatures, the weekly temperatures from the beginning of, from the 15th of June until October. So that's over the summer season. And the 4 different rows are represent the 4 different lead times. So the first one is 1 week before, second one 2 weeks, 3 weeks, and 4 weeks. So the white, the box plot, that's the actual forecast. And the blue shade behind, that's what the information we would have from climatology, so from the past 20 years for that same week. And the red dot represents the observation, so the actual weekly, the average temperature that was measured there. So we can see, if we look at the week 1, we can see this the 2 first episodes I mentioned. So in June, the second part of June here, there was quite a deviation from climatological values, and also in August, it's quite patent there. And however, if we look at the forecast from week 4, these were not that well captured. But as we go further in time, week 3 not so much. Week 2 a little bit. You can see that the forecast is moving a bit away from climatology, but still the forecast itself is not that announcing, it's not telling us that much about the warm event. However, week 1 forecasts are a lot better, and we can see how the forecasts were accurately predicting that extreme. So what the definition we used for extreme event in this case was that the forecast probability was above 40% of the climatological percentile of 90 of the climatology. So in this case, I've marked at the bottom with these triangles are the actual events that, applying this definition, we got. So in Stockholm there were 4 events in June, 2 weeks, and then August, and then the one in September. And then when did the forecast actually predict these events? So we had 3 warnings for Stockholm, and those were issued the week before. And we see that these 3 warnings were correct, all 3 of them. However, the last one was missed. The forecast was not indicating this. So the way to measure this, we use a deterministic evaluation. So I'm showing here for each one of the weeks the hits, the false positive, misses, and the correct negatives that the system had. So this, and then we compute an evaluation metric. One is the hit rate, and the other one is the threat score. In this case, we have the same results, but the threat score is a bit more restrictive, and it penalizes for the false positives. So we can see that we had skill in the first week. However, in the other weeks, there's no skill. Also, this is a very small sample, so there were three cases, and they were missed by the forecast at these lead times. Now I'll show another city. So we move on to London. In this case, you can see at the bottom the actual events. So similar for June, 3 weeks in a row in August, and then in September. And again, the forecast, there were not warnings issued with this definition for weeks 4, 3, and 2. And however, in week 1, sorry, there were three warnings, and all of them were correct. So this is the score that we get for week 1. So it's a 0.6. Okay, and then one last city here. We go to Madrid. So in this case, in the south, there haven't been those episodes of that extreme heat. In fact, with our definition, we only get 2, and only one of them was captured, which was the one in July. So there's not a lot of sample here, but this gives us an illustration of the way to evaluate the service we were issuing. And just to say that we had good feedback with this service, so, and particularly from energy companies, and it seems that knowing in advance this episodes of extreme heat is quite useful because it affects directly the demand. So we had feedback that even the idea was to have this service in summer, but that is quite useful. So even going into winter, it was interesting for them to have this information. So we're actually continuing the service throughout autumn and winter. So that's all. Thank you.
Great, thank you, Andrea. We have a few questions. So the first one is for Andrea. How did you choose the 40% threshold for the extremes?
Thanks. Well, that's a good question. This is an arbitrary choice, so we wanted to have a warning, but if you lower too much the probability, you might have many more events. And we wanted this to be some sort of a warning that doesn't happen that much. So to have an event that is not that likely to happen, to really highlight when it's something particularly impactful.
Right, thank you. So we have a comment for Llorenç. Great presentation on seasonal forecast, clear and useful. Thank you from Antonio. And then a few questions for the Euro-Atlantic Teleconnections. Can we compare the probabilities you're showing from the model to the occurrence of the different patterns over the last 30 years? Basically looking at probabilities relative to a normal winter.
So if I understood the question right, the question is about how frequently those teleconnections are occurring with respect to the issued probabilities. If that's the case, I have to say that the rank probability skill score, that is the score that we evaluate in the hindcasts. So we have a hindcast from the climate data store that covers the 1993 to 2016 period, and we have the retrospective forecasts of the teleconnections for those years. I think it's like 24 years or something like that. So we can verify the forecast for those 24 years, and for the rank probability skill score, it takes into account the issued probabilities. It's a probabilistic verification metric, so it somehow verifies the calibration of these forecasts. But we do not have a reliability specific reliability diagram or anything like that yet ready. Well, we could do so.
Thank you, Llorenç. And a few more questions. How is the skill of the Euro-Atlantic teleconnections in other seasons?
Okay, yeah, that is something that we have investigated in the project during the research that we've been doing. In general, what we see is that different teleconnections are predictable at different lead times in different seasons. So it varies a lot, but for instance, in spring, if you take the lead zero predictions, they are very good for all the teleconnections, for all the 4 Euro-Atlantic teleconnections. If you go to summer, both the NAO and the Scandinavian pattern are predictable up to 3 months ahead. So I think there is a very good opportunity there to use those 2 teleconnections in summer. In autumn, the results are the worst for all the seasons. So in autumn, it would be difficult to use those forecasts. It would be dangerous to use those forecasts. And in winter, there is a skill depending on the teleconnection up to 3 months, but the better results, of course, are obtained at lead 1 or even better at lead 0. So if you wait for a few more days, we can have a better picture for what's going to happen in DJF, when we have the new runs from all the systems, probably 15th of December.
Right, and one final question, Llorenç. How are the Euro-Atlantic teleconnection forecasts computed?
Well, the idea is that we first compute the teleconnection patterns for each season with geopotential height at 500 hectopascals. We do that with reanalysis data with ERA5, and once we have the patterns, then we take for each system and for each member, we take the anomalies of 500 geopotential height anomalies, respect the climatology of each prediction system, and we see how similar those patterns are, those anomalies patterns are to each of the teleconnection patterns, and that gives the strength of the teleconnection index. And then we gather the result for all the ensemble members. That's what we do. A bit simplifying a bit the story.
That's great. I will give just a few moments more for any additional questions. And in the meantime, I want to inform the participants that we're hosting an event on climate forecasting for energy. It's a free one-day workshop that's happening on the 4th of December and is organized by S2S4E together with OpenMod. And I have added the link to the chat. So if you're interested to find out more about the latest research, then you can have a look at this event. And it's free to join, but you need to register beforehand. So there are no more questions at the moment. So thank you everyone for taking part in our webinar. And we will see you at our next events, hopefully. Thank you, and thank you, Andrea and Llorenç.
You're welcome.
Bye.
Goodbye.
Thanks.
Bye.